In this video, we're going to look at displacement reactions, in particular the displacement reactions of halogens for an example of a longer answer question. So let's have a look at the question we've been given. We have aqueous solutions, chlorine, bromine and iodine, and solid samples of potassium chloride, potassium bromide and potassium iodide. And we want to describe, so there is a command word there, how you could use these chemicals to demonstrate relative reactivity of the three elements. So we're going to need to talk about all three elements in our answer. It's a comparison question, but we're also asked to include observations, and it also says full, balanced and ionic equations for the reactions. Useful piece of information at the end. We don't need to include details of practical equipment, so we're not asked to think about how we mix them together, what we add them in, or anything else. So one thing hopefully you'll notice is I've underlined 4 things, and this is an 8-mark question. So to get our full 8 marks, which is our ideal, we need to do these 4 things. We need to describe what we're going to do. We need to say how that tells us about the reactivity of the elements. We need to say what we see, observations, and we need to include at least one full equation and at least one ionic equation. So one thing I'm just going to recommend, normally students are really good at highlighting and underlining. Here I go. I've underlined. You could be going quite far down the page, and what I notice is people do that highlighting and underlining process, then they don't necessarily sort of go back to it or refer to it. They sort of forget about one once they start writing. So what I want you to do is, if this was at the bottom of the page or the bottom of the answer space would be bigger than this for 8 marks, but obviously with PowerPoint unrestricted. So at the sort of near the bottom, I'm going to write down describe reactivity. I need to talk about reactivity. Compare really is what we're looking at there. Observations, full equation and ionic. So I've sort of picked out the main bits of the question and written it sort of somewhere further down the page. That sort of should act as a reset, so that when I'm writing I can then just go back to that list and I can tick it off. So I can say, hey, yeah, have I described? Have I finished describing? Have I compared the reactivity of all 3? Okay, so little box around that. Let's think about what we should do first. So first, we need to say what we're going to do. We need to start with describing the experiment. We can also think about what we don't need to do and how specific we are. So what we don't want to say is we're just going to add chlorine to the other things. We want to say what we would add chlorine to. So we could add chlorine to separate samples. So nice and clear, because I don't want to say I'm going to add chlorine to potassium bromide and potassium iodide, because I'm not sure whether I'm adding them together or not. I'm also not going to add chlorine to potassium chloride. We'll get onto that at the end in case that's a question that comes up, why we don't do that. So separate samples of, now I'm going to use the formulae, KBr and Ki, just because it's quicker to write. However, do be really careful. Remember, if you're going to start using formulae, make sure you know what they are. Maybe check with your equation that you write that you've said the same thing. And I'm also going to say that I'm going to add bromine to separate samples of KCl and Ki. And since it doesn't take much to add it, I'm also going to say add iodine to separate samples of KCl and KBr. Now, in theory, we can get the relative reactivity just by adding chlorine to bromide and iodide, and then adding bromine to iodide. So in theory, that does give us a sort of pecking order of reactivity. However, because those are the three reactions that do result in a reaction. However, you know, at GCSE and everything else, we're sort of taught that we're going to also just check that it doesn't work in the opposite direction. So that iodine does not displace chlorine or bromine. So that's the absolute sort of maximum number of experiments that you would do. What we certainly don't want to do is we don't need to, there are 6 things that we've added together there are 6 separate samples. We don't need to talk about all of the equations because there's only going to be 3 reactions. So the only reactions that are going to happen are chlorine is going to displace bromide and iodide, bromine is going to displace iodide. So there are going to be 3 things when no reaction takes place. Okay, when we have done that, it would make sense to do some balanced equations. Now, how can we make that easier? One thing we can do is I'm going to refer to my different experiments. I have no idea why my letter's quite disappearing like that. It's very weird. We're going to refer to them as A, B and C. And then what we can do is show how they link together in our equations that we do. So A is adding chlorine, and then B is adding bromine, and C is adding iodine. So it's really, really clear which bit we're talking about. So for A, I can start to write some balanced equations. I want a full balanced equation, so I'm going to start with Cl2 plus 2Ki, I'm starting with the iodide, and 2KCl plus I2. It does not talk about state symbols, don't need to add those in. And then, since I'm already on that, I could write an example of a ionic equation. Now, if I've got all the time, you know, if I'm chilled and I got lots of time in this exam and I've done other things, I may well now sit down and write a full equation for chlorine plus potassium bromide to make bromine, and then I could do the ionic equation for that, and then I could move on to experiment B and I could do an experiment for show bromine to potassium iodide and write an equation for that. The thing is though, you're not showing any new skills, so writing one full equation is exactly the same with the halogens as writing any others. So actually what I'm going to do is I'm going to go, well, I've done an example of a full equation and ionic equation. Let's work on the rest of the stuff. I've also done my description, described what I'm going to do, what I'm going to add to what. Now, I really want to look at the reactivity, the comparisons, the observations, in case my time is tight, because otherwise I've not fully answered everything they've asked for, and I'm definitely not going to get 8 marks in this question if I don't do that. So we still have observations. Now, I would have just written a balanced equation. Let's say that I've written 2 ionic equations, because those are going to be the things that tell me what I see. And then there are chlorine plus 2I minus goes to 2Cl minus plus I2, and then I can also add bromine, and I minus goes to Br minus plus I2. So quick check, what is coloured, what is not. Halides, bromide, chloride, iodide, they're not coloured. So we can get a bit confused because the halides, the silver halides are, that's how we test for them. But think logically, you know that sodium chloride is just a white salt. All things that don't contain transition metals are generally going to be not coloured. So potassium or sodium bromide, chloride, iodide, they're going to be white solids, and then when they dissolve in water, they're going to be colourless solutions. So that's one thing we need to know. All halides, except the ones that contain transition metals, are colourless. So it's the halogens that have the colour, but this is in water. So you may have learned, oh yes, chlorine is a green gas, but nobody's using gaseous pure chlorine. It's in solution. Think about a swimming pool. You can't see the colour of chlorine in a swimming pool. You can't see the colour of chlorine in tap water. So Cl2 is colourless. Again, colourless solution. It's only therefore the bromine and iodine that have any colour. Now you may have learned that bromine is brown. That's a bit of a problem because so is iodine in aqueous solution. So in this sort of question, it's a good idea to say that Br2 is orange, say. That's probably being a bit optimistic anyway, because there's probably not much of it produced. And then we can say that I2 is brown. So then all we need to do is underline what we start with. We're only looking at the halogens because they're the only possible things that could have colours. And now we can write our observations, and I am going to write observations for all three of the reactions that happen. So that is going to be colourless to orange, colourless to brown, and orange to brown. And then we can say that all the other reactions, there is no reaction. That's probably a bad way to phrase it, actually. Let's say all the other mixtures. There is no reaction and therefore no colour change. Just so we've been clear that there are three reactions that don't happen. So we've done equations, we've done ionic equations, full equations. We've said what we're adding to what. We've said that 3 of them do react and 3 of them don't by writing the equations for the reactions that happen. And then we've linked our ionic or our full equations to the colours by looking at like what is coloured and what is not in the reaction. So we now need to make sure we talk about reactivity, relative reactivity. So we, at the very least, need to say which is the most and which is the least. The question hasn't mentioned displacement. The title of the video is displacement, but that doesn't mean it's going to be in front of your mind. We need to talk about it. So we can say that chlorine displaces bromine, and that is because chlorine is more reactive than bromine. We can also say that bromine displaces iodine because bromine is more reactive than iodine. Now you could, if you want, talk about iodine being the least reactive, iodine not being able to displace anything. It's implied that iodine is the least reactive because you've said that chlorine is more reactive than bromine, and then you've said that bromine is more reactive than iodine. So you also know that chlorine is more reactive than iodine. You don't need to keep going around the bush with like everything. If you're really not sure and you're thinking, how could I make it really, really clear that I know what I'm talking about with reactivity, we could just go Cl2 greater than Br2 greater than I2. There we go. I've definitely put them in order. So make sure you've got some sort of order somewhere, some comparison with that mentions all three of them compared to each other. This is okay. Displacement. Displaces bromine. You may be wondering about the language. Should you be saying chlorine displaces bromide? That's perfectly acceptable, and of course, I am a fan of saying bromide because we start with bromide. However, displacing elements is fine to talk about it like that. Chlorine displaces bromine. However, you could be even better. If you want to really level up your language, you could say Cl2 is the strongest oxidizing agent, and it oxidizes, this case we do want the ions Br minus and I minus. You could then continue and say that bromine Br2 is able to oxidize I minus but not Cl minus. So that is a better way of saying they're more reactive, but in this question it's not needed, but be careful because you may have questions that relate it to redox and oxidizing power, in which case you probably want to talk about oxidation numbers, or at least look at the charges and the loss and gain of electrons that's going on. So chlorine is the most likely to gain electrons and become Cl minus, so therefore it's the best at gaining electrons, it takes electrons from other species, it's a good oxidizing agent. So let's just look at a couple of other ways that this question could go, because that was one example. One thing they could ask you to talk about is addition of cyclohexane or another organic solvent or a non-polar solvent. So when does this come up? We know that our Br2, which is aqueous, is, we're going to say we're calling it orange, and then for iodine aqueous we're calling it brown, but it's just a bit wishy-washy, because of course a dilute solution of iodine could look the same colour as quite a concentrated solution of bromine. So the reason that we add the organic solvent, such as cyclohexane, is that we shake it up, the halogen moves into the organic layer because halogens are non-polar, so they're more soluble in organic solvents, and you'll get two layers because the organic solvent won't mix with the water. So you get an organic solvent layer, and that layer will be still orange for bromine, but iodine is not brown. In an organic solvent, it's a very vibrant purple colour, and I can easily spot whether I have bromine or iodine by doing that. Okay, this reaction could be used to identify a halogen or a halide, more likely a halide. So for example, the question could talk about adding chlorine and using it to identify whether you had bromide or iodide or chloride present in your solution. So let's imagine you had Br minus, Cl minus and I minus. If you add chlorine, if it was chloride, nothing would happen, you'd see no colour change. If it was bromide, you'd see it turn orange. If it was iodide, you'd see it turn brown. If you really weren't sure whether it was orange or brown, you shake it up with some cyclohexane and see whether it goes orange or purple. Finally, another thing is if a question says, you know, perhaps they give you the practical details, then we say, why don't you add chlorine to potassium chloride? You know, as a valid question. And one of the things that most students are going to leap to is, oh, well, because they won't react. Okay, but neither will bromine and potassium chloride. So what you really want to say is that a halogen or chlorine specifically won't react in terms of displacement. It cannot displace itself. So that is what you're saying, rather than saying it won't react, because actually bromine cannot displace chlorine either, and so therefore you don't always add them together with the expectation of a reaction happening, but there's no point adding the same halogen.